Let's now move to the final part and let's talk about clouds. Let's talk a bit about clouds. Everyone, or let's say a lot of people, uses this term cloud computing, and it's a bit of a mess in the sense that there are a lot of variations and a lot of understandings about what this is. I'm not trying to cover all of them here or to give an exhaustive taxonomy of the thing, especially because nowadays it's not only about cloud computing. You probably have heard terms about IoT, Internet of Things, edge computing, fog computing, and all these things, they share some similarity, but they also have different aspects and so on. But if we just focus for a moment on cloud architectures, if you put it in a very simple way, the idea is that you have a set of physical machines of servers. Each of them uses virtualization to run several guest operating systems and processes within each guest operating system, so that companies can rely on third-party companies that provide such virtual machines to run their services, maintain their data, run their code, and so on and so forth. You have, of course, a lot of variations here because you can think about public cloud infrastructure. So basically, I don't know, something that is what Google offers, for example, or Microsoft do. Or private cloud infrastructure. You can have big companies that have their own servers and they use their own hypervisors and their own guest operating system to virtualize all the services they provide. So everything stays within the company, but it's still a cloud infrastructure. Then you have, of course, different levels at which you can offer services, and we're going to look at this in detail in the next slide. You have differences. Sometimes you're talking about big machines and small machines. If you were to, let's say, define a set of characteristics that you are interested in, it's, of course, you want on-demand and self-service provisioning of resources, right? So when you need a machine, you can connect and use that machine. It doesn't need to be always on, always accessible. It's when you want it. Here, always accessible, I don't mean that you cannot connect to it when you want. What I mean is that it doesn't need to be on and waiting for you all the time. It gets instantiated when you want. You want broad network access, right? So you want to be available via network with standard mechanisms. You don't need special hardware or special software to connect to it. You want to create pools of resources so that you can give them depending on the demand. You want elasticity, which is a complicated topic that we are not cover here, but the idea is that in principle, if you're running, for example, certain analysis and one core, it's not enough, then you should be able to scale up the analysis by adding additional cores and increasing the parallelism degree, maybe for a while, because you are observing a spike of volume of data, so you need more computational power. But then if the data goes down again in size, then maybe you can decommission some of the cores you don't need and go back to using less cores because it costs less. And of course, you need to have a good measuring of what you are actually consuming, what resources you are using, how much you use them, because you pay only for what you actually consume, not just to keep the machine always there and always running as you would do probably with traditional physical machine that you use for a specific purpose. Now, these are the different type of services you can offer. So you can have the so-called infrastructure as a service. So here the idea is that you provide the entire virtual machine and then you connect to it remotely and you use it. Okay, it can be an SSH connection and you just use the terminal to operate on it, or you can have a graphical user interface. You are basically connected to your computer that is remotely maintained and run by an hypervisor somewhere else. You can have a service that is the platform as a service. Here it's not just connecting to a virtual machine, but it's connecting to a specific environment. Okay, so you can connect and use a specific operating system. You have a specific database installed there. So if you want to maintain data, you already have everything installed and a set of functionalities that allow you to maintain the data. You can make similar examples with web servers if you want. And then you have software as a service. So in that case, you are connecting to a virtual machine, but what you are using the virtual machine for is only to execute a specific software. And this is what you are actually seeing. So you're not allowed to operate on the entire virtual machine or go and change something in the file system if it's about files that are not managed by that software. You just get there to operate on a specific piece of software. Now, something that is a must when you go into the cloud infrastructure that I think it's interesting mentioning here is that of the virtual machine migration. So we said in the very beginning of this lecture that one of the benefits of virtualization is that if you need to, let's say, do some maintenance work on your physical server, you can suspend the execution of a virtual machine, store its state, and then turn it on again, start it again once you are done with the maintenance. Of course, you can also take the entire virtual machine and move it to a different piece of hardware and give it to another hypervisor and then ask that supervisor to execute it. Now, the idea is simple. The problem is that, of course, if you are offering a service and customers are paying only for the amount of time or the amount of resources they use, you cannot penalize them and you cannot disrupt the service by actually turning off the machine, copying the data somewhere else and turning on the machine again. If the virtual machine is very big, that might take even minutes. And of course, it's not really nice to offer a service in which all of a sudden your machine might be turned off and can be inaccessible for a certain amount of time, especially because you might not really know when that is going to happen, and that might affect your business. So research here is conducted to perform what is called as live migration. So to provide mechanisms that allow to transfer one virtual machine from a certain hypervisor running on a certain hardware to another one in a seamless fashion. The goal is that the transition is happening, but you as an user cannot really experience or observe that this is happening, which is something that is also close in spirit to fault tolerance. This is also what fault tolerant research on fault tolerant solution is about. Many times you want to be able to tolerate faults, but without the user being affected by them or not significantly affected by them. So now the question is, how do you do this for a virtual machine? Something interesting here is the concept of checkpointing and snapshotting. So in a very simple way, the idea is that you continuously keep track of what is changing in your virtual machine. So you have the memory and you have control of the pages in the memory because the hypervisor is the one that actually intercepts the request of the guest operating system and allocates frames on the physical memory. And then you have the file system, and as we said, this can actually be a file that is maintained by the hypervisor. So with checkpointing and snapshotting, the idea is that since the very beginning of the execution of a new virtual machine, okay, you start building an incremental backup of all the information that is about this virtual machine. The initial one can just be the base one because you create a virtual machine that is, let's say, the virtual machine that runs Ubuntu 16. You have an image, so you can already have that as a backup. If you want to turn on a new or create a new virtual machine with that operating system, you don't have to install the operating system from scratch. You can just take the copy and consider that as the starting point. And then keep track of whatever is being updated during the execution. and periodically perform updates on your backup so that when you have to migrate something, you can start from the latest backup and only update what was changed since the time you created the backup to the time you are actually performing a migration of a virtual machine. So now you need to combine a mechanism that keeps track of what is being modified in memory so that you can replicate that and apply those changes to the latest backup. But you can make everything more smooth in the transition because you can take the last checkpoint snapshot and move it to a different virtual machine without really interrupting the execution of the current virtual machine. And if you are able in a lightweight manner to keep always incremental snapshots with a fine-grained resolution, then this is basically the mechanism that allows you to achieve seamless live migrations.